So let us solve some problems on the protection. So the first problem is a three-phase transformer having line voltage ratio of 0.4 kilovolts by 11 kilovolts is connected in star delta, and protective transformers on the 400 volt side have a current ratio of 500 by 5. So what must be the ratio of protective transformers on the 11 kV side? Okay, so here protective transformers means the CTs and PTs. Okay, so of course if they are connected in series, that means they are CTs. So it is a three-phase transformer and its line voltage ratio is given, that is 0.4 kilovolts and 11 kilovolts on the primary side and secondary side. Primary side it is 0.4 kilovolts, on the secondary side it is 11 kilovolts, and on the primary side it is star connected, whereas on the secondary side it is delta connected. So on this 0.4 kilovolt side, that is 400 volts. Okay, 0.4 kilovolts is nothing but 400 volt side. The current ratio of the CT is 500 by 5. Okay, and you have to determine the ratio of protective transformer, means the ratio of this CTs on the 11 kilovolt side. Okay, write down the question. As soon as you complete, inform me. Did you complete? As soon as you complete, type C. So here this transformer is star delta connected. Okay, that is, it is star connected on the primary side and delta connected on the secondary side. So on the primary side, the CT that is connected on the primary side will be delta connected, and the CT that is connected on the delta side will be star connected. So just for your not understand the concept, I'm showing you here. So you can see here, this is star connected on the primary side and secondary side it is delta connected. So CTs that are on the star connected side are delta connected, and CTs on the delta connected side are star connected. Okay, So it is line voltage is 0.4 kilovolts, that is 400 volts on the primary side and 11 kilovolts on the secondary side. Okay. So now now let us assume that the line current on 400 volt side is 500 amperes. Okay, so already they have given some ratio here, current ratio of 500 by 5. So let us assume the line current is 500 amperes. Now phase current of the delta connected CT on 400 volt side will be 5 amperes. Okay, so line current is 500 means phase current will be 5 amperes depending on the given data that is from the in the problem. So the line current of the delta connected CT on 400 voltage side you can calculate. We just multiply this phase current 5 into root 3. You will get 5 root 3 amperes. If you want, you can solve it. Okay. So this 5 root 3 will flow through the pilot wires on the secondary side. You can see here in this image, 5 root 3 is flowing to the. So, okay. So whatever current is there in the secondaries of CTs which is flowing on the for the secondaries of the CTs which are connected to the primary side, same current will flow through the secondaries of the CTs which are connected to the secondary side. Okay, so the phase current of the star connected CTs on 11 kV side is 5 root 3 amperes. Okay, write it down. As soon as you complete, inform me. Okay, now if I is the line current on 11 kV side, okay, then primary apparent power will be equal to the secondary apparent power. So primary apparent power is what root 3 into primary voltage into primary current, and similarly secondary is root 3 into secondary voltage and secondary current. Okay, so these are all the line current, line voltage and line currents actually. So root 3 into primary voltage side is what, primary side voltage is what, 400 and current is 500. And similarly, secondary side root 3 into voltage is 11 kV. And I, we don't know, we have to determine it. So you just simplify it, you will get I equal to 200 by 11, that is nothing but 10.5 amperes. So CT ratio on 11 kV side is what? This 200 by 11, that is 10.5 is to 5. Okay, it's not 10.5 maybe. Okay, you just solve it later on and you will get the value. So 200 by 11 is to 5 root 3. Okay, so 200 by 11 is to 5 root 3. You just simplify it, you will get 10.5 is to 5. So CT ratio on the 11 kV side will be 10.5 is to 5. Write it down. As soon as you complete, inform me. Okay, similar to this problem, let us solve one more problem. So a three-phase transformer of 220 by 11 kV line voltage is connected in star delta. The productive transformers on 220 volt side have a current ratio of 600 by 5. What should be the CT ratio on 11 kV side? Okay, it's similar to your previous problem, almost same. So it is also a star delta connected, means it is star connected on the primary side and delta connected on the secondary side. Definitely the CTs on the star connected side of the transformer will be delta connected, and the CTs on the delta connected side will be star connected. Okay. And let us suppose that the line current on 220 volt side is 600 amperes. Okay, current ratio is given, and 220 volt side current ratio is 600 by 5. So the phase current on the delta connected CTs on 220 volt side will be 5 amperes. So you just convert this phase current to line current, similar to your previous problem. Okay, write it down, and as soon as you complete, inform me. Okay, so let us proceed. So for your sake, I am showing you this image. So this is the primary side, which is star connected. This is the secondary side, which is delta connected. And on the primary connected side, the CTs are connected in delta. On the delta connected side of transformer, CTs connected are in star. Okay. So I have converted this phase current to line current of the CTs of 220 volt side, that is 5 root 3 amperes. Okay. So this is the current that will flow through the pilot wires. That is 5 root 3 is the current that will be flowing through the pilot wires. Okay. So now the same current will flow through the pilot wires of the secondaries of the CTs on the 11 kV side also. Okay. So the phase current of the star connected CTs on 11 kV side will be 5 root 3 amperes. So let us assume I is the line current on 11 kV side. So primary apparent power equal to secondary apparent power. So root 3 to 20 into 600, root 3 11 kV into I. So you just simplify it, you will get I equal to 12 amperes. So it is similar to your previous problem. Only the numerical values have changed, that's all. Write it down. Okay. Okay, if you know I, you can calculate the turns ratio similar to your previous problem. Okay, so CT turns ratio is what? 12 by 5 root 3. So 12 is what? 12 by 5 root 3. You just simplify it, you will get 1.385 by 1. Means 1.385 is to 1. This is the turns ratio of CTs on 11 kV side. Just write it down. Okay, next problem. A star connected three phase 10 megavolt ampere 6.6 kilovolt alternator is protected by circulating current protection. So the star point being earthed via a resistance R. Okay, you have to estimate the value of earthing resistance if 85% of the stator winding is protected against earth faults. And you have to assume an earth fault setting of 20%, neglect the impedance of the alternator winding. Okay, so it is a star connected three phase 10 megavolt ampere 6.6 kilovolt alternator. Okay, and just for your convenience, I'm showing you here. This is the stellar decision. This is the stator winding of the alternator, which is star connected. Okay, and it is 10 megavolt ampere, 6.6 kilovolts alternator, and it is three phase. And it is protected by circulating current protection. Let us assume. Okay, and the star point of the stator windings is grounded via a resistance R. Okay, so it is grounded via a resistance R. You have to estimate the value of earthing resistance, this R value. This is the earthing resistance, isn't it? So you have to estimate the earthing resistance of if 85% of the stator winding is protected against earth faults. Okay, so if 85% of the stator winding is protected against earth faults, you have to determine the R value. Assume an earth fault setting of 20%. Okay, so earth fault setting is provided in the relay, that is 20%. You have to neglect the impedance of the alternator winding. Okay, so this is the given problem. Note it down. As soon as you complete, inform. Write down the question, and as soon as you complete, inform. Okay. So here it is mentioned here that the earthing resistance, um, of course, you have to determine the earthing resistance if 85% of the stator winding is protected against earth faults. So the 85% of the stator winding is protected against the earth fault means 15% of the stator winding is not protected. Okay. So here only 85% is protected. That means 15% is not protected. It is unprotected. Okay. So that we must keep in our mind. Okay. So let R is the small r, of course, they have already mentioned in the problem. So R is in ohms, be the earthing resistance required to leave 15% of winding unprotected. Okay. So this resistance R will leave the 15% of the winding which is unprotected. And so this R value's duty is to protect up to 85% of the winding. Now let us determine the full load current. Okay. So P is equal to root 3 VI. So I equal to P by root 3 V. Okay. So what is P? 10 megavolt ampere. So 10 into 10 power 6 by root 3 into what is V? 6.6 into 10 power 3. So you just simplify, you will get 876 amperes. Write it down. Okay. Now minimum fault current which will operate the relay is mentioned in the problem, that is 20%. So 20% of the full load current. So 20% into 20 by 100 into full load current is 876. Just now we have calculated. So 20 by 100 into 876, you just simplify it, you will get 175 amperes. So 175 amperes is the minimum fault current which will operate the relay. Okay. And voltage induced in 15% of the winding, okay, is 15 by 100. 15% means 15 by 100 into P by root 3. I'm sorry, V by root 3. What is V? That is 6.6 into 10 power 3 by root 3. You just simplify it, you will get 330 root 3. Okay. So this is the voltage that is induced in 15% of the winding. And the earth fault current, which 15% winding will cause, will be equal to the voltage induced by R. Okay, I is equal to V by R. So I is for 15% winding, you have already calculated the voltage induced for 50% of the winding, which is unprotected, that is 330 root 3. Okay, so that voltage by this R will give you the earth fault current, which 15% winding will cause. Just write it down. Okay. Now we have already calculated the minimum current. Okay, we have already calculated the minimum current, minimum fault current which will operate the relay. So the minimum fault current which will operate the relay is 175 amperes, and the earth fault current which 15% winding will cause is 330 root 3 by R. So these two must be equal. Okay, so the minimum fault current which will operate the relay must be equal to the earth fault current which 15% winding will cause. Okay, so 175 must be equal to 330 root 3. So 175 equal to 330 root 3 by R. You just simplify it. R is equal to 330 root 3 by 175. You will get R equal to 3.27 ohms. So this is the resistance. Okay. So this is the earthing resistance. Okay. So which will protect 85% of the stator winding against earth faults. Okay. Write it down. Okay. Let us solve one more problem. So a star connected three-phase 10 megavolt ampere 6.6 kilovolt alternator is protected by mass price circulating current protection principle using 1000 by 5 amperes current transformers. The star point of the alternator is through a resistance of 7.5 ohms. Okay. And if the minimum operating current of the relay is 0.5 amperes, calculate the percentage of each phase of the stator winding which is unprotected against earth faults when the machine is operating at normal voltage. Okay, so you have to calculate the percentage of each phase of the stator winding which is unprotected against the earth faults. Okay, so it is a star connected three-phase 10 megavolt ampere 6.6 kilovolts alternator which is protected by March price circulating current protection. Okay, so it is same image I can show you. This is a star connected alternator with earthing resistance is given. This R value is 7.5 ohms. Okay, and it is provided with multiply circulating current protection. Same image you can, if you want, you can draw in your exam. Otherwise, no need. Okay, it will be more easy to understand if we draw the circuit. Okay. So let us assume since we have to determine the minimum, percentage of each phase of the stator winding is unprotected against the earth fault. So let's assume that is X percentage of the winding is unprotected. Okay. And the earth resistance R is equal to 7.5 ohms, which is given in the problem. Okay, we'll continue. You just complete this writing. Just write it down. in your notes. As soon as you complete, we will proceed further. Okay. Now, let us estimate the voltage per phase. Okay. So whatever line voltage that is given, that is 6.6 into 6.6 kilovolts, you can write it down as 6.6 into 10 power 3 by root 3. You can determine the phase voltage. If you solve it, you will get 3810 volts is the phase voltage. And minimum fault current which will operate the relay is your in your problem they have given multiply circular current principle using 1000 by 5 amperes current transformers. Okay, so current transformer ratios are given, that is 1000 by 5. Okay, so 1000 by 5 into multiply with the minimum operating current of the relay is 5.5 amperes. Okay, so multiply with the minimum operating current of the relay, that is zero point 0.5 amperes. So 1000 by 5 into 0.5, you will get 100 amperes. Okay, so the EMF induced in the percentage winding, which is unprotected, it will be equal to phase voltage into X by 100. Phase voltage is what? 3810, which we have already calculated. This is X percentage, that is X by 100 I have written. So that is nothing but 38.1 X volts. Okay. So EMF induced in X percentage winding is 38.1 X volts. So the earth fault current which X percentage winding will cause will be equal to the EMF induced in X percentage by R value. R value is already given in the problem, that is 7.5. Okay. So just write it down as soon as you complete info. Okay, if my voice was breaking because of the network connection that I have used, Just now, my voice is not breaking. I have changed the connection. You didn't note down the question? Okay, note it down. Make it fast. You have written only half question. Okay. Make it fast. I'm sorry. This is not the problem. This is the problem. Okay, right. Yeah, yeah. I have changed it. Okay, shall I change the slide? Okay then. So I have already explained. You have to determine the voltage per phase. Okay. And later you have to determine the minimum fault current which will operate the relay. After that you have to determine EMF induced in X percentage. This X percentage is the notation that we have assumed to determine the unprotected winding percentage. And we have determined some earthing fault current which X percentage winding will cause, I value. Okay. So definitely this earthing fault current which X percentage winding will cause must be equal to the minimum fault current which will operate the relay. Roll number 19223. Okay. So the earth fault current which X percentage winding will cause must be equal to the minimum fault current which will operate the relay. Okay. So definitely. So 100 must be equal to 38.1 X by R. What is R value? 7.5. So if you substitute 7.5 and equate this whole expression with 100, you can determine the X value. Okay. Shall I vary this slide? Okay. So here you can see I have equated 100 with 38.1 X by 7.5. So I have determined the unprotected uh, percentage X value. So here I have not written percentage unprotected. So you just simplify it. You can determine the percentage of each phase of stator winding which is unprotected against the earth faults. This is the percentage of the stator winding which is unprotected. That is 19.669% is unprotected against the earth faults.